All right, so what you need to remember for this activity is that this number right here, this A, this is always the initial value. That's the starting value, right? Initial means like the starting value. Okay, so whatever you're starting with, like for example, this case, Luna has $200 in a savings account. That's her initial value. That's how much she's starting with. Okay, now this number right here, this is the most complicated one. This is either the growth factor or the decay factor. Okay, now it's one or the other. If it's greater than 1, it's a growth factor, right? So that would look like something like I'm starting with 100%, I add whatever it is, 3%, that's 103%, that becomes 1.03. So that's like an example of a growth factor. Whereas a decay factor is always less than 1, so that looks something like 100%, we're losing 5%, so that's minus 5%, that's 95%, and that becomes a decimal like this, that's less than 1. Okay. Now this x value, this always represents the number of time periods. Sometimes those time periods are weeks or years or days, whatever it is. Okay, so that's basically all we need to know. So when I read this problem, I'm just trying to kind of plug in these pieces. So here, Luna has $200 in a savings account that earns 2% interest. Okay, so the first thing I see is that she has $200 to start with. That's my initial value, so I'm going to just go ahead and plug that in right where the A is. Now, it earns 2% interest. We're talking about a growth factor here, right? Because we're starting at 100%. We're going to add 2% interest. So that's going to be 102%, which becomes 1.02. That's going to be my growth factor. So that's going here. Okay. Now, we put x here, but here's the thing. This x is the number of time periods. So it says, to the nearest cent, how much will she have in 3 years? So I'm going to even erase the x. I'm going to go ahead and put the 3 here. This is just what goes in my calculator. I'm literally just going to type exactly this in my calculator. 200 times 1.02 to the power of 3. Okay, there's my answer. Now, it says to the nearest cent, right? That makes sense. If we're talking about dollars and cents, I'm going to go to the nearest cent. So let's write this down. This is $212.24, right? Cents is like if I have something $7.99, it's the decimal point and then 2 numbers after. So I'm going to chop off that 16. Let's say this was like a 7 or an 8, it would round this number up. But in this case, it's not. All right. So this would be my answer that I would put in IXL. Let's take a look at another one. Now this one's longer, but you just got to read to find the information you need. Thanks to its environmental initiatives, Bloomington has cut its annual CO2 emissions by 5%. So already I'm thinking, oh, look, we're talking about cutting something. That's reducing something by 5%, which is good, right? Like we don't want, emissions are bad. That causes smog, right? Pollution stuff. Okay, so we're going to be subtracting 5%. This year, the town produced 220,000 metric tons of emissions. If the downward trend continues, how much CO2 will be produced 7 years from now? Okay, so here's what I see. I see we're starting this year at this many tons of emissions, and that number is going to go down. So we have, right, this is going to be this, changes to a decimal. Okay, so that's going down. Now, the number of time periods is, in this case, it's 7 years. So it's going to go down 5% 7 times, right? So that's why we're going to basically multiply by this number 7 times. That's what the exponent does. So let's put it in. 220,000 times 0.95 to the power of 7. Okay, so in 7 years, we're going to be producing way less CO2 emissions. Now it says the nearest whole number, so make sure you're rounding correctly. Here, the nearest whole number, right, is this without a decimal point. This is a 2, so it's going to round down. So this becomes 153,634. Okay, and that's metric tons of emissions or whatever it is. Okay, all right. These last two, there's some a little different, a little new in there. You have 856 grams of radioactive kind of barium. If its half-life is 5 minutes, how many grams of barium will be left after 15 minutes? Okay, so first thing, I can see that I'm starting with 856 grams. Now, a half-life. A half-life is certain materials, they decay, and half of it like dies off basically in a certain amount of time. So when we're talking about taking half of this, we're talking about a growth factor. A decay factor. You could think of it like this, like it's cutting in half, that's 50%, and that's 0.5, right? But what I actually want you to realize is that multiplying by 0.5 cuts something in half, right? Like if I take 856 and I multiply it by 0.5, that cuts that number in half. That's what it does. So basically what's happening is this is being divided in half every half-life. Now, how many times is it going to be divided in half? Well, a half-life is 5 minutes. That means this particular substance, every 5 minutes, it divides itself in half, okay? So if after 15 minutes, how many half-lives would that be? Well, each half-life is 5 minutes, so this is going to be 3 half-lives. Okay, so this is going to be a 3. This is basically, I'm multiplying 856 times 0.5 3 times, right? I could even look, I could even do this, right? Look, I'm going to get the same answer. It's 107. Watch, if I do this same thing, this is just using exponents to do the same thing, right, to the power of 3. It's 107, all right? But this is 107 grams. Okay, a town's population is currently 12,050. I'm right away like, okay, cool. Let me just write this down, right? If the population doubles every 6 years, what will the population be 12 years from now? Okay, doubles. What am I multiplying by? So like here, remember I was multiplying by half, which actually ended up dividing it in half. If I'm doubling, that means multiplying by 2. So I want to take this number, and multiply it by 2. Okay, now how many times am I going to multiply it by 2? Right? In this case, it's doubling every 6 years. It's doubling every 6 years. So I'm not multiplying it by 2 every year. It's doubling every 6 years. So 12 years from now, it'll have doubled twice, right? This is 2 doublings because it only doubles every 6 years. So first 6 years, it doubles once, and then the next 6 years, it doubles again, and that's been 12 years. So it looks like this. So I'm going to put 12,050 times 2 to the power of 2. You could even put times 4, right? But 482. And you can see, like, you could have even just put in your calculator 12,050 times 2 times 2, right? And you would have gotten the same answer.